Yeah, once again, good afternoon, all. Good afternoon, all of you.
Good afternoon, sir.
Good afternoon, sir.
Yeah, before entering or jumping into the topic, just we can check the syllabus. Now, we are discussing about the third unit, that is schema refinement. Yeah, we done first normal form, second normal form, third normal form, DCNF also, right? Or no? We completed up to DCNF with examples. All of you clear about that? Hello? Is there any doubt on that up to DCNF? If any doubts, please ask me. Otherwise, you tell. If it is okay, then I will go for next topic. First normal form, second normal form, third normal form, DCNF. All of you clear? All of you understood those topics? All of you applied those things or normal forms in your database? Hello? No one is responding means what should I understood? Silence means understood or not understood or what? Don't know. Is this my voice is audible first of all?
Yes, sir, audible.
Yeah. If it is audible, you should tell you whoever having your things, maybe that first normal form, second normal form, third normal form, and BCNF. If it is understood, then okay. Otherwise, any problem is there, you ask me. If you are in silent means I cannot understand what is going. Please reply.
Clear.
Clear. Remaining. Quickly, they are very important topic. That is what I am taking more time to complete these topics. Remaining students, all of you clear? Hello?
Yes, sir.
Okay. Anytime if you are going to ask anything also, I will show this type of mechanism. If you are having examination, payments or other things, you will ask to me, right? You are posting messages. Immediately I am responding, but I will do same your process. Okay? Shall I do like that? Whenever you are having any problem, I'm also taking same part like what you are doing. I'm asking if you are understood or not. If you are understood, you tell. Otherwise, you ask me then so that I can discuss again. Quickly, don't waste the time.
Yes, sir. We understood.
Yeah. Okay. Then coming to the syllabus, uh, after BCNF, generally we have fourth normal form and fifth normal form. But in syllabus, they are given lossless and decomposition and multivalued dependencies. So before entering into fourth normal form, we must know the multivalued dependencies because here fourth normal form always avoids the multivalued functional dependencies. So that we need to learn what is multivalued dependencies, then how to identify the multivalued functional dependencies. All these things we need to learn before entering into the fourth normal form. So that's why we can have the same platform for this multi-valued functional dependency under fourth normal form only. So that once fourth normal form we can understand, fifth normal form is very easy. Now before that they are given lossless join decomposition. Already we are discussing every time for every after normalization. After completion of the normalization, we are verifying that decomposition is right or wrong. Means with help of lossless join and dependency preservation. Yes or no? You are verifying or not? After
Yes, sir.
normalization, yeah. Again, in the syllabus they mentioned so that you know the meaning and how to check everything. Even though in a mathematical representation they are given in your book, and we will discuss so that we can get more clarity. After that, we'll go for the multi-valid functional dependency. What is the multi-valid functional dependency? And how we are going to identify all these things we will discuss today. If possible, we'll start fourth normal form today. Otherwise, we will discuss tomorrow fourth normal form and fifth normal form, so that we will finish the syllabus of third unit. So I have taken more time for normal form. I think you are identified. Why I am taken? It is very, very, very important. DBMS only because of this normal forms only it is implemented. So that is why here I taken these minutes of time for completion of this normal forms. Maybe I hope you understood why I have taken. Clear? All of you clear?
Yes, sir.
Yeah. Right. Now coming to the decomposition. Already I told you. Here lossless joint decomposition. Already after decomposition, why you are going to decompose? Here we have the redundancy in the table, so that we need to avoid the redundancy, so that we are going to find functional dependencies. Based on the functional dependencies, we have to find which normal form it is suitable. So after identification of the normal form, based on the normal form, you are going to decompose the relation into multiple relations. So after decomposition, maybe there is a chance of the problem, maybe the data loss or maybe the any other issue. To solve that particular problem, we need to check the properties of decomposition. The first property is lossless joint decomposition. Means after decomposition or after dividing of your tables, after applying of normal form, we can get multiple tables. Here after that, is there any data loss? Because we are dividing, right? So that there is a chance of data loss. Then how to know that data loss is not happened? Here while joining these two tables, it must be shown as a result table. How the table is there before decomposition. So like that, if it is going to show all the records like the before decomposition, then you can understand that there is no loss of decomposition, so that your normalization is right, so that your decomposition is right. Look, there is no problem. So this is actual story already we discussed earlier. Every time we are checking yes or no. Clear this? Critically, right? Even though for experimental also we did yes or no. Hello, all of you clear about this lossless giant decomposition?
Yes, sir.
Please reply quickly. Right. Now, in a mathematical way or maybe the proof, okay, as per the book, okay, we need to use some of the technical terms as an engineer, so that we will discuss. Let R be a relation. R is a relation. If you take R is a relation schema and consider F is a functional dependency, F plus is a closed set of functional dependency. F is a functional dependency. Yes or no? As per the previous class discussions. Yes or no? Hello? Yes or no? F is a functional dependency, right? Capital F. F plus is a closer set of functional dependency. Yes or no? Hello? 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 Is this my voice is audible? Hello?
Yes, sir.
Audible.
Yeah, please reply that. If you are identified, this screen is visible, moreover?
Yes.
Yeah. Now, if you are having a relation R and you are identified a functional dependency which is R, clear? Clear? Hello? Hello? Functional dependencies we are going to refer by F, capital F. Yes or no? Please respond quickly.
sir.
Now you know the functional dependencies. You know what is the functional dependency means? We are going to verify one attribute is depending on another attribute. Like that, if you are identified a two schemas like X and Y in a relation R, which contains maybe the X related and Y related schemas are there, is lossless join, which are lossless join. Means we have divided the relation into X is one relation, Y is another relation. If you take like that, here, which is to be a lossless join because of the functional dependency. We are identified functional dependency on R. Based on that, we have divided X is one relation, Y is another relation. Now, if we are after decomposition of the relation, here we need to check lossless join that decomposition is done or not. So for that, every instance R of R that satisfies this phi of X projection, you know, phi of X of relation joins with phi of X of relation that must be matched to the original relation. Already I told you. For example, here this is SP and this is PD. Here SP, S1, P1, S2, P2, S3, P1. Now PD. Here P1, D1, P2, D2, P1, D3. Here these two things were decomposed. From this table, we are decomposed into these two tables. After decomposition, we need to apply this join operation. What is the phi SP of this SP of R? Natural join phi PD of R. Now all these tuples are available or not, we'll check. S1, P1. Here S1, P1, P1 is there so that we can get D1. Here S1, P1, D1 record is there. Yes. After joining, the results I am showing. Now S1, P1. Here, where is the another P1? Here another P1 here also there. So that we will get one more record. S1, P1, D3. S1, P1, D3. Here this is one. Now coming to the S2. From S2, P2. S2, P2. Here P2 only one record. That is S2, P2, D2. S2, P2, D2. Yes, record is available after joining. Now S3, P1. Here S3, P1. Again P1 having two records. So that S3, P1, D1. S3, P1, D1. Yes, it is. Next S3, P1, D3. Yes, S3, P1, D3. Now, after joining of this D2 decomposed table, we'll get this result table. Here, now you check these all records are there in the original table or not. S1, P1, D1 is there here. Check me S1, P1, D1. S1, P1, D1. Yes or no? It is there. Correct? Hello?
Yes, sir.
Yeah. Next one is the S2, P2, D2. S2, P2, D2. Here, this also there in this table. Now, S3, P1, D3. S3, P1, D3. Yes, this is also there. Is there any data loss?
No, sir.
Is there?
It's lossless.
Yeah. The same, whatever we discussed earlier, already we know. But even though with practically in separate topic we are discussing, this is simple. Okay. Here, this is a lossless. So that after decomposition, if you are using normal form is in a good mechanism with help of functional dependencies, if you are identified normal forms very clearly, after decomposition, compulsory it is a lossless join decomposition we will get. Understand? All of you understand?
Yes, sir. Got it.
Yeah. In the same way, in theorem, sometimes exams, people are asking theorem also. That is what? If you take a theorem, mathematical proof, it is there in your grammar book also. Let R be a relation and F be a set of functional dependencies that holds on R. The decompose, you can understand. If you know this, all this information with example, this theorem you can easily understand. Please carefully read, then you can write your own way also. The decomposition of R into relations with attribute sets, that is R1 is after decomposition, R1 is one relation, R2 is another relation, is lossless join if and only if F plus, that is a closer set of functional dependencies, you know very well. Then this is a functional dependency. Based on the functional dependencies, we can apply Armstrong axioms and we'll get the closer set of functional dependencies. Contains either the functional dependency R1 union R2 determines to R1 or R1 intersection R2 determines R1 or R1 intersection R2 determines R2. Simple. Simple. Compulsory these two columns having one column compulsory determines. So if you observe SPPD, compulsory there is a common column is what? Tell me. In these two tables, what
P.
is the common column? P. So
P.
that is what we are telling here. R1 intersection R2 determines R1 or maybe R1 intersection R2 determines R2. So maybe R1 will come or R2 will come after the intersection of R1 R2. That is the meaning of commonality attribute in the both the relations. That is the meaning. Nothing is there actually, but technically we need to find. In other words, the attributes common to R1 and R2 must common a key for the either R1 or R2. Just I told you this. P is a common. Clear? So that we can achieve the dependency. Clear?
Yes, sir.
Yeah. Now this is the lossless chat. Now coming to the dependency preserving decomposition. Dependency preserving. Just I told you common attribute is there in the both the relations. There is a chance of dependency preservation. As I told in the earlier, this property allows us to check integrity constraint. Exactly. Because when you go for the how the integrity constraint will come based on this dependency preservation, I will tell you. Here, integrity constraint means it is dependency. For example, wherever P1 is there, we need to map that P1 from this table. So P1 is there, P1. You're mapping, right? P1, P1 means it will be mapped to two records. So here P2, only one record is there, it will be mapped. Means it is this this column or this attribute is depending on this attribute. So compulsory, whenever you are going to read the related record, wherever it is there, you are going to map. So that is what dependency preservation. If you are applying dependency preservation, that is an integrity constraint. Your conditionally data is evaluated. That is why if we are using dependency preservation, it is going to check the integrity constraints effectively. Understand? Understand? Hello?
Yes, sir.
Yeah. In simple, a dependency preserving decomposition allows us to enforce all functional dependencies by examining a single relation on each instance or modification of server. Exactly. Just now. So this is what? Each instance. It will be checked. P1, okay, matching. P1, P2 is not matching. Never command. P1 is matching. Like that, for this dependency preservation, it will check everyone. There P2, P1 not matching. P2, P2 matching. P2, P1 not matching. Like that, here it is going to check every individual record that is going to applicable for this functional dependency or not. Clear?
Okay, sir. Clear.
Yeah. Mathematical representation of this dependency is let R be a relation schema that is decomposed into two schemas as we told just now, X and Y. Let F be a set of functional dependencies. Because of the functional dependency F, the relation R is decomposed into two schemas. One is X, another one is Y. Now, the projection of F on X is the set of functional dependencies is the closer F plus. So we are going to identify even closer functional dependencies also based on functional dependencies which involves only attributes of X. We denote the projection of F on attribute X as F. Simple. Here like that, we are going to find if you want to use closer set of functional dependencies that is called as F plus. Like that, here functional dependencies of X union functional dependencies of Y, which is closer, we can use plus. Here that is union is equal to all closer set of functional dependencies. This is a theorem, it is proven, but this proved theorem is not given in your syllabus. Okay, you must remember. Clear? Logic here is very simple. Here we are divided to relation x and y. The functional dependencies of x and the union functional dependencies of y, which is equal to combination of relation R functional dependency f plus. That is what I said. Sir, no.
Yes, sir.
Yeah, that is what simple. So this all the things are whatever I told you. That's it. Here this is not there in your syllabus. They removed schema refinement, database design. They removed. Now the next topic is, I think everyone has understood this, lossless joint decomposition. Clear?
Clear, sir.
Yeah. Now we'll go with multi-valued dependencies. Here, why should we learn multi-valued dependencies? Even we learn so many functional dependencies, full functional dependency and partial functional dependency. Here, full functional dependency and partial functional dependency we learn for the second normal form. Yes or no? Because second normal form is going to avoid the partial functional dependency. Yes or no? Yes or no?
Yes, sir.
Yeah. Now, trivial dependency. Here we learned trivial dependency. Sometimes they will ask directly questions. What are the functional dependencies are available? You can write all these things. That is why I am recalling the trivial functional dependency. Where it is, we discussed about this trivial dependency.
Third normal form, sir.
Third normal.
Transient dependency.
Even fourth normal form also, BCNF also said. Here, third normal form and BCNF normal forms, they are avoiding the trivial functional dependency. They will accept only non-trivial mechanism. But the difference is in third normal form, here that x, if you write x determines to y, maybe there is a chance of x is a candidate key. But in a BCNF, you can write same x determines to y after decomposition of the relation because of the trivial mechanism. For example, x determines to y, y determines to z. Then we need to write x determines to y one separate table, y determines to z one separate table. But in a third normal form, this x and y may be the candidate keys. But in a BCNF, same procedure, x determines to y, y determines to z. But trivial mechanism is not possible, so that we need to decompose xy is one table, yz is another table. But this x and y must be a primary key. Yes, this is the difference between BCNF to third normal form. Both are avoiding the trivial mechanism, but BCF in the form of candidate key and third normal form in the form of candidate key and BCNF in the form of super key. Correct? Yes or no?
Yes.
Yeah, means every normal form is depending on one category of functional dependency. Understand?
Yes, sir.
Yeah. Now the fourth normal form also in the form of multi-valued dependencies. Fourth normal form is going to avoid the multi-valued functional dependency. If we wanted to check how to check that given relation is in a fourth normal form, means we need to check that given relation is in a third normal form, BCNF, third normal form, second normal form, first normal form, so that we can apply the fourth normal form. Before applying the fourth normal form, we need to check that relation is having any multi-valued functional dependencies. If the relation is having any multi-valued functional dependencies, we need to avoid these functional dependencies by decomposing of our relation, so that the relation will be converted into the fourth normal form. This is the story. Clear for the fourth normal form? Clear?
Yes, sir.
But we don't know what is multi-valued dependency, so that we are going to discuss now what is a multi-valued dependency, then how to recognize that multi-valued dependency, so that we can apply fourth normal form. That's right. Now we are going to learn about the multi-valued dependencies. Okay? Is it okay?
Yes, sir.
Yeah. Now coming to the multi-valued dependencies. Simply, we'll check with example, then you can understand. Here, I don't want to go for theory. With example, we'll go for this. Please don't confuse. Things are actually very easy, but people will confuse because if you are going to understand with example, things are very easy. Okay, is it okay? Hello.
Yes, sir. Okay.
Yeah. Yeah. Now, if you consider one table, the table is one vendor code, item code, project number. If you observe for V1, there is a I1 and P1. Again, V1 I am taking, there is a I2, P1. If you take item code is not depending on vendor code. Yes or no? In this case, V1 is there, I1 is there. Again, V1, I2 is there. Item code is depending on vendor code. Item code is depending on vendor code. Hello?
No, sir.
No, it is not depending. That is what? Now, if
Independent,
you,
sir.
yeah, independent. If you take again, if you take project number is depending on vendor code, up to this actually ask you.
Yes,
Project
sir.
code, yes, it is depending. When comes to V1 again, V1, what happened? I1 means these two records may be depending, right? Item code depending on vendor code, right? Wherever V1 is there, I1, V1 is there, I1. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Now here V1 is there, P1, and here V1 is there again, P3 is there. And that's why here V1 is there, I2 is there here. Again, these two records are matched. V1 is there, I2, V1 is there, I2. Are you following?
Yes, sir.
Yeah, that's why here, here there is no exact all matching things are there. Here there is a multiple uh, tuples are matching. Means here if you take this is T1 tuple, T2 tuple, T3 tuple, and T4 tuple. If you observe, T1 and T3 is matching. On the form of vendor code and item code, I am telling. You don't take project number here. Understand? And T2 record tuple is matching to T4. Yes or no? V1
Yes, sir.
I1 and V1 I1. V1 I2, V1 I2. Here means here it is two times dependency. Here one is one. Some tuples are matching to another some tuples. Some of the other tuples are matching to some of the other tuples. So there is no direct dependency. There is a multiple times the dependencies are vary. Are you clear? Dependencies are coming, but multiple times are the dependencies are coming from your table. Are you clear? Are you clear?
Yes, sir.
So
Yes,
that
sir.
is called as multi-valued functional dependency, MVD. Here people will confuse you. Actually very simple. Multi-valued functional dependency. Simple. You don't judge. You need to read total complete table only. You fix it. Don't first second record. If you don't, sir, there is no dependency, so that I cannot do that. No, no, no. You need to check entire table. There is a chance some of the tuples are equal. Here, this tuple is equal and T2, T4 are equal. So like that, we can get some more other tuples also if you go for that. V2, then I2. V2, I3 is there. And V3, I1, V3, I1. Yeah, these tuples are equal. Yes or no? Yes or no?
Yes, sir.
Yeah. Yeah, such type. Different mechanisms will come, but some tuples are equal. Yeah, such type of mechanism is called as multi-valued dependency. All of you clear the definition? All of you clear? I'm sure I showed example also. All of you
Yes,
clear
sir.
this?
Yes. Yes, sir.
Here, before entering into the fourth normal form, we will discuss some more things on multi-valued functional dependency, please. Okay, because it is very important. People will confuse on this. So if you understood really the multi-valued functional dependency, the fourth normal form is very easy, and fifth normal form there is no any scope of functional dependency, but it is very easy. I will show you in the next class. Today will complete this multi-valued functional dependencies. Here, if you consider, based on this example only, I am showing again, based on this example only, we can understand whatever I am telling. Please, I am reading carefully, you observe. Here, given a relation schema R, you are taken any relation, the name you take consider as a R. Let X and Y be a subsets of attributes of R. Maybe R contains so many attributes, X, Y, Z, like that, like no problem. So many attributes are there. But just you are taking X and Y are two subset of attributes of R. Yes, I can take X and Y are two attributes of R. That is, X and Y need not be distinct. Means X and Y there is no distinct. Maybe some tuples are equal like this. Understand the definition? Maybe there is a some tuples are equal. There is not distinct, because distinction means here V1 I1 will come. No need to come any other tuple V1 I1. That is compulsory. Different values will come. That is a distinct. So sometimes values will equal. Sometimes values are not equal. That's why you cannot tell that is not a distinct. Understand the meaning? Not be a distinct. Understand? Hello?
Yes, sir.
Yeah. Then the multi-valued dependency denoted as, we have to denote if it is like that. How it is? So some of the values are same. That's why you can tell vendor code double describes item code. That is what? Tell if it is like that X and Y, then you can write X determines to Y. So the meaning is, this meaning is multi-valued functional dependency, that is MVD. You have to denote. Generally, how to denote the functional dependency? X determines to Y. But the multi-valued functional dependency, we need to write X determines to Y. So that is what multi-valued functional dependency. Clear? Clear? The representation of multi-valued functional dependency is clear?
Yes, sir.
Yeah. Now, if the multi-valued functional dependency X determines to Y satisfies in a relation R, which is if a given two tuples T1, T2 in R with T1 of X equal to T2 of X. Just now only I told you that this is what. T1 equal to T3. T1 of X equal to T1 of Y. So that is the meaning. Understand?
Yes, sir.
Yeah. So T1 of X equal to T2 of X. Where the tuples, if in your table is having T1, T2, means 4 records if you are having, then same X value is T1 of X equal to T2 of X, sometimes T3 of X equal to T4 of X. So all these 4 tuples, we don't know which tuple, where it is going to match. But if it is like that, then where the Y values of T1 and T3 are same and the Y values T1, Y equal to T3Y and T2Y equal to T4Y. Just now I told you that these other tuples are equal. T1, T2 and T4 are equal. Like that, that is the Y values is equal. Understand? Understand?
Yes, sir.
Yeah, for that you can write R minus relation, complete relation is R minus X minus Y. Values of T1 and T4 are same, and the R minus X minus Y value of T2 and T3 are the same, like this. The T1 and T3 are same, T2 and T4 are same. Yes or no? Yes or no? Hello? Hello? Yes or no?
Yes, sir.
Yeah. So that we can write T1 of R minus X
Yes, sir.
minus Y equal to T4 of R minus XY, or T2 of R minus X minus Y equal to T3 R minus X. So these two relations we can write based on these tuple equivalents. So this is what, so when if you want to take one example for this tuple, for this multi-valued dependency. Before that, this tuple multi-valued dependency is understood, everyone? If you understood, I will go with example. All of you understood?
Yes, sir. We will.
Yeah, if you understood, then just now same example I told you. Now what happened? Here there is a multi-valued functional dependency on vendor code determines to item code. So this is the multi-valued dependency. Here, so that we determines to I. Here we need to decompose the relation into your vendor code, item code into one table, here and vendor code and project number is another table. So this is what actually fourth normal form. I will tell you, don't worry. Fourth normal form we will discuss some more with examples. Uh, Even though your course and teacher and book, tell me, is there where is the function multi-value functional dependency? Please identify. Identify the multi-value functional dependency in this example. The decomposition is fourth normal form. We will discuss next class. Please identify multi-valued functional dependency in this example. Please quickly.
Teacher depending on code.
Teacher. Hello.
Depending on code.
Aha, that don't tell. This is having multi-valued functional dependency or not? Is this having multi-valued functional dependency or not? Hello.
Yes, sir.
Yes. If it is yes, tell me. Here, what are the tuples are equal? Yes, Anusha is telling right. Codes, teachers. But
Yes,
tell
sir.
me
Like a
the
physics 101 and the book mechanics.
T1 tuple and
T.
T2 tuple is equal, correct?
Yes, sir. Again, T3 and T4 are equal.
T3 and T4 equal. And again, what happened?
Like all T5, T6, T7 are equal.
These three tuples are equal. But when you observe, when the green is there, there is a chance of physics 01 or there is a chance of maths 301. Yes or no?
Yes, sir.
Means what happened? What happened? Here, when green is there, teacher green is there, maybe he will teach physics 101, physics 101, physics 101, or maybe he will teach
Maths.
maths.
Math ones.
Means here, instead of writing 1, 2, 3, 4, 5 times, we can write only 2 times. Yes or no? Yes or no? But
Yes, sir. Yes, sir.
for two different functional dependencies. Because whenever you write a green, because Bhaskar, if you take myself, here you don't write only Bhaskar is going to teach only DBMS. Sometimes if you are going to write, Bhaskar is going to teach DBMS, Java, maybe the data structures, like that we can write more functional dependencies will come. Yes or no?
Yes, sir.
Yeah, so that here teacher, here multi-valued dependencies is coming, multi-dependencies is coming. Means here teacher determines to course, correct?
Yes, sir.
Yeah. So that's why such cases will come to the real-time examples. If you take, that there is a chance of multiple dependencies. That is what multi-valued functional dependency. Now understand how to identify multi-valued functional dependencies?
Yes, sir.
Yeah. Here we'll go with one more example. Right. So now X, Y, Z. Tell me, in this example, what are the multi-valued functional dependencies? What are the tuples are same?
T1, T3 and T2, T4.
Yeah, A, B1 and A, B1 is there, correct? And
Yes, sir.
A, B2 and A, B2 is there. Yes or no? Means
Yes, sir.
these two tuples are same. Again, these two tuples are same. Means multi-valued. Means
Yes.
if I take what happened, 1, 2, 3, 4 records is came. If I decompose this relation, one relation will get, we can write A, B1 and one more is A, B2.
B2.
This is enough, right? This is enough, right? But A is having multiple things. One is B1, one is B2. Yes or no? Yes or no? Hello?
Yes, sir.
in this original table, we have written 4 times. Instead of writing 4 times, we can write 2 times only. So that is what multiple dependencies. That is what how to write x determines to
Determines
y. This
y.
is what multi-valued functional dependency. Clear this?
Clear, sir.
Yeah. Just bookish definition. Just I am reading because we need to know when we are going to write examination. Therefore, each x value in such a relation, there will be a set of y values associated with it. This association between the x and y values does not depend on the value of other attributes in the relation. Same thing. In above example, we have two tuples T1 and T2 in relation are defined on relation schema R with the same x value, that is A. We exchange the y value, that is B1 and B2 of these tuples T1 and T2, obtain the y value of tuples T3 and T4. Then the tuples T3 are the same. So this is what exactly we know. Now understood everyone? Multivariate functional dependencies are understood?
Yes, sir. Understood.
Yeah. Now when we are going to define the multi-valued functional dependency, very important topic in this multi-valued functional dependency. Please, here, just we are implemented only functional dependencies. Based on functional dependencies only, multi-valued dependencies we are identified. Yes or no? Directly we have taken only functional dependencies, right? F only, right? We are not considered F plus, right, till now. Yes or no? Whatever the examples I told you just now, we have taken only functional dependency. Means there is no closer set of functional dependency we have not taken. Yes or no?
Yes, sir.
So that even in a multi-valued functional dependency, there is a chance of closer set of functional dependencies. So that we need to learn now. Tomorrow we will apply on fourth normal form. We are coming to the first rule. Here you know already old rule only. What is that? Reflexivity. Here what is the reflexivity? X reverse subset are equal to y. Then you can write x determines to y. Same rule we can use for identification of closer set of functional dependencies. Clear? Clear.
Clear.
The second rule is augmentation. Same rule, augmentation. That is, if x determines to y, then we can multiply z both the sides. That is, xz determines to yz for all any z. This is also same rule for Armstrong accent sound rule. Yes or no? Clear? Clear.
Yes, sir. Go. Yes, sir.
The third rule. The transitivity, same rule like whatever you implemented in the functional dependency, same. That is, if x determines to y and y determines to z, then you can write x determines to z. These three rules are same rules we can use in the multi-valued functional dependency also. Clear? Clear?
Yes, sir.
Along with that, here additional three rules we can use to find the multi-valued functional dependency, that is a closer set of functional dependencies, that is a F plus. So the fourth rule is MVD complementation. Please remember these rules are new. So for multi-valued functional dependency. Note it down, please. So what is that? If x determines to y, then we can write x determines to r minus xy. The meaning is very simple. For example, R is a relation. If you take R contains X, Y, Z, K, M. Like that, these many attributes are there. Are you clear? Hello?
Yes, sir.
Yeah. These many attributes are there, but you are identified a multi-valued functional dependency between X and Y. Here.
Yes, sir.
How to identify multivariate functional dependency? Just now I shown with so many examples. I think everyone is aware of that. Yes or no?
Yes, sir.
Yeah. Now, after identification of x determines to y, based on this MVD, multivariate functional dependency complementation rule, we can write x determines to means x multivalued dependency on remaining attributes of xy of relation R. Means you remove xy attributes from R, you remove these two. Means what are the remaining? Z, K, V. Also multi-valued depending on X. This is the meaning. If you write X multi-valued on Y, if you write X multi-valued on Y, even though MVD complementation rule, you can write X multi-valued on after removing of xy of R relation. That is what R minus xy. We don't know how many are there like this. Understand?
Yes, sir. Understood.
Yeah. Next one is the fifth rule. Very important. Please, all these rules you please note it down. If you are having any doubt, you ask me. MVD augmentation. You know already augmentation. How we are going to use augmentation in our normal functional dependency. In the same way, we can use multivalued functional dependency. That is, if X multivalued functional dependency Y and W reverse subset are equal to Z, then we can multiply this. W is left side and Z is right side. So generally, the augmentation rule in a functional dependency, what we have taken only that Z we are going to apply for both the sides,
Both
X
sides.
to
Yes.
Z. But here, when we are going to apply augmentation for multi-valued functional dependency, if it is your identified X multi-valued functional dependency Y and W reverse subset are equal to Z is there in that table, in that relation means that relation contains W also that relation contains, Z also contains, and remaining attributes also contains the relation. If you are identifying X determines to Y, and also you are identified W is a reverse subset of Z, then we can multiply W to left LHS and Z is to RHS. That is WX multi functional dependency on YZ. Clear?
Yes, sir.
Yeah, these are the new rules. Please remember and note it down for closer set of functional dependencies of multi-valued functional dependency, please. The next one is the transitivity, multi-valued dependency transitivity. Please, the rule is going to change in the multi-valued functional dependency. All these are F plus rules I am discussing. You know very well. These are F plus means closer set of functions. These three are functional dependency.
Functional dependency.
Yeah. Now MVD transitivity. General transitivity, how is it? X determines to Y
Y
determines to
determines
Z,
to Z.
then we write X determines to
X.
Z.
Yes.
Exactly. But in a multi-value transitivity is not like that. If you are identified X determines to Y, Y determines to Z, then what we can write? X determines to Z minus Y. Please remember. We cannot write X determines to Z. We need to write X determines to Z minus Y.
Y.
Yes, you need to minus it. X determines to Z minus Y. That is what. Clear? Clear?
Yes, sir. Yes, sir.
Yeah. Now the coming to the seventh rule, replication. Your replication is not there in your functional dependencies. Now multi-valued closed set of functional dependencies, it is there. That is, if you want to write replication X determines to Y, then directly you can write X multi-valued functional dependency of Y. This is what replication. Clear?
Yes, sir.
Yeah, simple. Now last rule, eighth rule, somewhat people will feel it is very tough, but please follow, then you can understand very easy. Colson's. The Colson's rule, it is if X determines to Y and there is a W such that W intersection Y means I will write if you take R, W, X, Y, Z like that, so many attributes are there. Like this, in this relation. Now there is a W. Yes, W is there. There is a W. So this is a W. And you are already identified X multi-valued dependency on Y, and we are identified W such that W is intersection of Y is empty. When you are going to apply intersection with W and Y, will get empty. Empty means No element means there is no common element from W2 to Y. Clear? If there is any common element, you can apply intersection, you will get as a output. Yes or no?
Sir.
But here I am applying W intersection with Y. Here I am getting empty. Means there is no common attribute between, common value between W and Y. Understand? Understand?
Sir.
Yeah. So that we can write W determines to Z. That even though if you are identified, W determines to Z and Y reverse subset are equal to Z. Y is a reverse subset or equal to Z, then you can write X determines to Z. Then you can write, because these all three conditions are there, then only you can write X determines to Z. That is, if you are identified X determines to Y, and if you are applied W intersection with Y is a empty, and the functional dependency W determines to Z if you identify these three conditions. At the time of Y, subset or reverse subset are equal to Z, then you can write, then we can write X determines to Z. So this is what Olsen's rule. Clear? These are the 8 rules we are going to use to identification of multi-valued functional dependencies. 3 are F rules, remaining 5 are F plus rules. You can use and identify multi-valued functional dependency. Clear, all of you?
Yes, sir.
Yeah, everyone is understood multi-valued functional dependency? All of you understood this multi-valued functional dependency?
Yes, sir.
Yeah.